So this is our geometry project by David, Yamada, me, and Charles. So this is the introduction. So our project is the movie project, or you can say the projector project. We study that the dilation can measure the ratio between the small image and the zoom picture on the wall. We decide to measure the throw distance and also where you should place the projector. So later we'll have a example of a projector, and a projector's throw ratio is defined as a distance which we will use d to represent the distance measured from lens to screen that a projector is placed from the screen. So divide the width, so we will use W to represent the width of the image that will project D and W, so it will project the distance and the width. Yeah, so this is the diagram. And so this will be the formula. D over W means distance over width equals 2 over 1 equals 2. Movie time. The end. Geometry project by David Yao, Yu Yamada, me, and Charles Kim. So this is the introduction. Our project is the movie project. We study the movie project or the projector project. We study that the dilation can measure the ratio, not radio, between the small image and the zoom picture on the wall. So this is our geometry project by David Yao, Yu Yamada, and me and Charles. So this is the introduction. Our project is the movie project, or you can say the projector project. We study that the dilation can measure the ratio between the small image and zoom picture on the wall. So the small image and the zoom picture means like enlargement and reduction. And so we decide to measure the throw distance and also where you should place the project. So later you'll be seeing a picture with a projector on it. So a projector's ratio is defined as the distance. So we will use the letter D uh to replace as distance, and measure of lens to screen that a project is placed from the screen. Divide by the width. So we will use width to represent W of the image that it will project the distance and the width. So there you go. Here's uh the image, and today this is our objective. So this will be the formula. It will be D over W equals 2 over 1, and it will be 2. So in knowing this formula, a projector's throw ratio will provide you all of the information you will need to set up in a room. and the following examples will be better to explain how this project works. So example. So you know what screen size you want, but need to know how far back the project will need to be placed. So if a screen is width is 7 feet and the projector's throw ratio is 2.0 minus 2.4 to 1. Because the projector have zoom lenses, they also have a range of throw ratios, then you can place your projector anywhere from 14 to 16.8 feet away from the screen. So 7 times 2 and 7 times 2.4 equals 14 minus 16.8. So this is this is the end of this project, and this this will be our final answer, and this is it. Yeah, thank thank you for listening for our geometry project, and sorry for handing the proposals late for 4 days. Thank you.